Good evening, everyone. Welcome back to my YouTube channel. This is Catherine at Kunda Makerere University, still taking you through the tomato disease detection, looking into the abstract, like an automated system of tomato disease detection using computer vision and machine learning techniques is proposed. The system includes image acquisition, preprocessing, feature extraction, and classification phases to accurately identify the presence of common tomato diseases. Results from experiments conducted on the dataset of the diseased and healthy tomato plants show that the processed system outperforms traditional methods in terms of accuracy and efficiency. The implementation of this system can significantly aid in early detection and control of tomato diseases, thus improving crop yields and profitability to the farmer. So looking into the introduction, the tomato disease detection is mainly to eradicate the anomalies in tomato plants, thus enhancing agricultural productivity. This will help act as a checklist to the abject hunger in the world today. Different tomatoes will be collected, sampled to be able to model the AI model to be used to effect drugs and many others. Um, Mainly using leaves as my features. Like the data I'm using here is mainly leaves like images. They are acquired, preprocessed, segmented, feature extracted, and this is done in model training. And finally, we do the model testing. So the background of this is tomato is widely grown and economically important in crops in the world. However, it is subject to various diseases. So the motivation is to help farmers make informed decision on which disease it is and which drug to effect to the crop. So that was actually the main motivation, like to minimize the use of harmful chemicals and increase crop productivity. Because if you're able to make an informed decision that it is this, then we shall be eliminating that. On the literature review, several sets of research have been conducted in the past recent years in the discipline of tomato diseases detection using the data language and the machine learning techniques. These research works have been conducted on a variety of tomato plants and leaf diseases, which can give promising results for the detection of diseases. Some of the recent studies have been mentioned below to give an outstanding and evaluate a subject of research, along where the reader can be able to know the work which has been done till the field of tomato disease detection problems. The main aim of image processing is that it makes it easier to notice a disease area quickly than observing the whole area. It involves methods like calculating the medium, the optical local patterns, and the metrics of the infected area. And so these are some of the gaps that are in the literature. I feel like, as I was explaining, like limited accuracy of the current techniques. Like many current techniques for tomato diseases detection may not be able to accurately diagnose diseases, leading to a high number of false positive and negative positives. Then lack of large annotated datasets. Limited annotated datasets of tomato diseases hinder the development of high accurate AI models. This is in a case where you have datasets that are small, they are not enough, they're not sufficient. Then inadequate presentation of diverse tomato diseases. Existing datasets may not contain examples of all the different tomato diseases, leading to limited accuracy for diseases not represented in the training data. Then the limited ability to handle variety in the disease symptoms. Some AI models may struggle to accurately diagnose diseases in the presence of variety symptoms, such as effects on the different environment factors on symptom expression. Then the computational costs of some techniques. Some AI techniques, such as deep learning, can be computationally intensive and may not suitable for development in the resource-constrained environments. Then in the summary of my term paper contribution, as you know, we have been doing this along the journey. So giving a summary of everything, like transfer learning. Transfer learning is a technique in which the pre-trained model is fine-tuned on a smaller data set to solve the similar problems of limited data sets. You're having a data set is small and yeah, when you do transfer learning, you can fine tune to fit that data set. Then ensemble learning. Ensemble learning is a technique that combines the prediction of multiple models to produce an overall accuracy. You remember in software engineering, we work as teams, so you can be able to compare what has been produced by the different models and produce accurate results. Then the data augmentation is a technique that generates new training samples by applying various transformations to the existing training samples. This can help to overcome the limitation of small data sets and improve the robustness of the model on variety in disease symptoms. Then the deep learning is a technique that uses artificial neural networks to learn hierarchy representations of data. Deep learning models can be trained on a large data set to identify complex patterns. Like in cases where models are leaving out some patterns, you can use the deep learning to identify those insignificant constraints. Then I will not take you much into the methodologies, because if you follow behind in the videos, we have been talking about them, and in the abstract, I talked about those methods. So talking about the dataset description, this is the link to the dataset that I've used. My dataset is mainly image, and my images in this case are the leaves, the tomato leaves. Then in the data preparation and explanatory analysis, data collection, we collect the data, collecting the leaves. Then data preprocessing, collected data to ensure quality and consistency. Like we have to ensure that it's not biased. Data annotation, labeling the collected data to create a dataset suitable for training the machine. After collecting preprocessing the things, you are not like you label it, this is this to be able to make a clear data set. Then the data splitting, the annotated data set is split into training, validation, and testing. Like everything you train, you test as it is not relevant in use. Then the data analysis of the annotated data is to understand the distribution of diseases and identify the patterns or relationships between the data features and the disease labels. Then here you train the model on what to do. You evaluate the model on testing a set of measure in its accuracy in diagnosing the tomato disease. Remember, this is like it is using prediction. So after training it, you evaluate, is it really doing the rightful thing it's meant to be doing? Then talking about the AI model selection and optimization, like what makes you select this model? The data collection. Obtain a large and diverse data set of health and disease tomato images to obtain the model. Like, don't limit your data, collect enough to have a wider view. Data preprocessing, as I expressed above. Model selection, choose the suitable deep learning model. That model, as we said in deep learning, can be able to identify those hidden patterns and bring them onto the table. Then train the model. Hyperparameter tuning. What do we do in here? This is fine-tuning the model by adjusting the hyperparameters such as learning rate, number of epochs. Like here, you tune your model. If you train it and you see it is learning at a slower rate, you need to do that it can be able to learn things at a high rate so as we can deal in the time complexity. Then the model evaluation. Evaluate your model, as everything has to be done. You have to make sure the model is doing the right thing, like it's performing well. Then the deployment, the selected model in the real world scenario, monitor the performance and fine tune if further is necessary. We don't just deploy, but you go ahead and maintain what you're deploying. Then talking about the accountability. After selecting the model, you put into consideration the accountability, the model bias. The model should be tested for fairness and unbiasedness to ensure that it does not produce inaccurate and like nothing good in it when the model is biased. So you have to make sure it is not leaning on one side, but it is generally doing what it is meant to do. The data quality of the data is used to train the model must be ensured to prevent the model from making incorrect predictions. If you use data quality that is not good, then you're going to make wrong predictions. Then model transparency should be designed to evaluate in transparent manner to allow stakeholders to understand its workings and limitations to promote trust in its results. Then the model evaluation, I've really talked about this a lot. Model explainability should provide clear and understandable explanations for its predictions to enable stakeholders to understand how it arrived at a specific decision. And this increases like a user can be equally satisfied that, yeah, I'm doing the right thing, it is producing the right thing. Then in my results and conclusion, as the model predicts, we have the true positive, true negative, true false negative, false negative, false positive, like all those are predictions. We expect them to be done. So what do we do in those predictions? We use the confusion matrix, like you calculate the accuracy, the precision, the recall. As you can visit my behind video, it explains how you can calculate these confusion matrices. Then how are they sensitive into the model in the training dataset? The confusion matrix can be highly sensitive in the size and distribution of the training dataset. If the training dataset is small, then the model may overfit. And if the model overfits, it's not good. So it also contributes on your training when you're training the dataset. Then testing the dataset. The confusion matrix can be sensitive to the size and distribution of the testing dataset. A large testing dataset will provide a more accurate to estimate of the model performance. The distribution of the testing dataset should be represented of the distribution in the real world data to which the model will be applied. Then the validation test. The validation dataset is used to tune the model's hyperparameter. So when you divide the data, and this is for validation, it is going to be used to tune the hyperparameters, and poor choice of validation tests may result in two model overfitting or even underfitting. So increasing the number of validation iterations can improve the model's performance and also increase the computation cost. So what should we do? We should make sure the model has a high performance so we can increase the validation dataset. So in conclusion, the development of an AI-based tomato disease detection model is crucial for the efficient and effective management of tomato crop diseases. The model can provide farmers with valuable information about the presence and several of diseases, allowing them to make informed decisions, like making informed decisions about the disease management strategy. The use of advanced technologies such as machine learning, computer vision, help to accurately diagnose diseases, reduce the spread of infections, and ultimately increase crop yields. This can result in significant benefits for farmers, the environment, and globally food supply, which the increasing demand for sustainable agriculture, the development such as models will play a crucial role in ensuring the future of agriculture and food security. Making informed decision will ensure the future of agriculture and food security in our world. This is my link to my data set, then the link to the Python code, like where I trained my data from, the notebook. Then in acknowledgement, I thank my lecturer, my practical lecturer, Mr. Galwango Marvin, and the supportive environment around Makerere, for I couldn't do this without a favorable environment. These are some of the references. Visit the notebooks, the links, and you see more. Thank you for tuning in. Meet next time.